Okay, so we are on notes 5, and it's proofs with parallel lines. So we are starting our proofs today. And the first thing we want to note is the transitive property, which basically says if A is equal to B and B is equal to C, then A is equal to C. The substitution property says if A is equal to B and B can be substituted in for any equation. So the difference there is transitive is A is B, and B is C means A is C. But if it's substitution, that means you can put B in anywhere. So as long as A is equal to B, then you can use B in other places. So we're going to start our proofs. We are given that line L is parallel to line M. Remember that that's what that little sign means there. And P is parallel to T. We need to prove that angle 1 is congruent to angle 11. So we are going to use different types of angle properties, angle relationships to help us prove that. The way that we always start a proof is we do the given. So our given is right here. So we say line L is parallel to M and P is parallel to T, and that's our given. And I make it look a little bit more like a table because it's easier to see then. And then I'm going to try and get to angle 11. Well, I know that these lines are parallel, so I can go from 1 to 3. Angle 1 is congruent to angle 3. And the reason for that is because they are corresponding angles. And their corresponding angles are congruent. Then I know that 3 and 11 are also corresponding. So now I'm going to say angle 3 is congruent to angle 11 because corresponding angles are congruent. So that gets me from 1 to 3 to 11. Great. I know 1 and 11 are congruent. I have to give my final statement that says that. So when we prove something, we do 3 little dots. That means like therefore. Basically, it means like we proved. And we would say we proved that angle 1 is congruent to angle 11. And our reason for this last step is the transitive property. Because this is like A, so if A is congruent to B, and B is congruent to C, then A is congruent to C. So our last step is transitive property because we have 1 to 3, 3 to 11, so then we can use A to 11. And that's our first proof. Then we're going to do the next one. So now we're trying to prove that 9 and 4 are supplementary. We're going to start with our given and make it a table. My given is L is parallel to M and P is parallel to T. And that's my given. I do have to write the given every single time. I'm going to start with 9 and I'm trying to get it to 4. I'm just going to think for a second and I'm like, ooh, what can I say is true? I'm going to go with 10 first. So I'm going to say that angle 9 and angle 10 are supplementary. I know that 9 and 10 are supplementary because they are a linear pair. Then next, I've got to try and get it so that 9 and 4 are supplementary. So I'm going to go from 10 to 2. So I'm going to say angle 10 is congruent to angle 2, and that's because of corresponding angles. And now I'm at 10, then I'm at 2. Got to do one more to get to 4. So I can say angle 2 is congruent to angle 4, and that is by corresponding angles. And then I have to do transitive property to get to 10 to 4. So I'm gonna say angle 10 is congruent to angle 4, and that's by the transitive property. And then I have one more step. Hopefully you guys can still read it. Our last step is going to be that we proved angle 9, oops, I wrote my 9 backwards, and angle 4 supplementary. And that is by substitution. So basically, we did 9 and 10 are supplementary, so we made 10 and 4 the same, and then we had to plug it back in, use substitution for the 9, and say that they are supplementary. Next proof, we're going to start with our given. It says line L is parallel to M, and P is parallel to T, and that is our given. We are trying to get to prove that 5 is congruent to 12. So we're going to say that 5 and 7 are corresponding. Yes, they are corresponding and congruent. Corresponding angles. And then we can say that 7 and 12 are congruent. And that is because they are alternate interior. So here and here is alternate interior. So alternate interior angles are congruent. Then our last step, we need to say we proved angle 5 is congruent to angle 12. And that's by the transitive property. Because again, this is like A and B. A is congruent to B. B is congruent to C. So A is congruent to C. That is all our proofs on that page. We do have one other thing on the back. It's just one last thing. It says, prove that the points on a perpendicular bisector of a line segment are exactly those equidistant from the segment's endpoints. So put point C on the perpendicular bisector and prove that it is equidistant from each endpoint. So basically what we can say is we're trying to make it so that if we have a point C, that it would be a perpendicular bisector. So if I have point C here, MC is a line of reflection because it is the perpendicular bisector of AB. Follow the steps below and label the diagram. So if we have a reflection of CM, A becomes A prime, and then if you draw AC, it would obviously be the same. And then A prime C would be the same as B, C, and AC is equal to A prime C, which is equal to BC. So by the transitive property, AC is equal to BC. So basically, we're trying to prove that this would be the same distance to this point. And that is all we have for notes 5.